Hello, so I'm Raquel. I'll get into who I am in a second, but I just wanted to say thank you for joining. Thank you, Chip, for joining. Thank you for joining again, as always. And then what's your name?
Yep, I'm Rand.
Rand, hi.
The Y.
No, oh, hello. Nice to meet you. Did the buzz term 3D printer get you here?
Yes, I did hear about that. I'm like, I've actually never touched a 3D printer. I know we had a free one at the International Innovation Center for a bit there. So,
Oh, really?
So I figured, well, I might as well learn how to use it. And I know we got some at the library too. So
Yeah, perfect. Okay, yeah. Okay, I'm really excited. I'm glad that that was helpful. I geared this presentation, I detoured from what was originally set up. It was going to be SolidWorks, kind of heavy, more advanced topic about SolidWorks itself, but I'm like, you know what, the Tech Alley people, they probably need something a little lighter and more introductory level, so that's the goal. So yeah, so I'll have some more questions. I'll give my introduction. I will talk about the global SolidWorks user group mission, and then I will get into the content of having an idea to 3D print in a very simplified process of getting from point A to point B. The second half of the discussion will be open conversation. So I will start it off by sharing resources, but at that point, if you have resources, if anything that while I was talking, made you think about something you wanted to contribute, it was totally open conversation. And yeah, resource sharing and highlighted resources.
Did Brian give you a microphone?
Do you need me? Is my projection?
Well, no, because he gives a microphone for people to ask questions that gets recorded.
Oh,
Like that black microphone,
yes, I see.
the wireless microphone?
No, either I will bring it over and you can ask your questions or share your resources, or I'll do my best of job getting repeating the questions so that it's recorded for anyone that watches this afterwards. Okay. Alrighty. Okay. So I think I already kind of understand based off personal conversations. I might be pointing to you, Rand, about, do you know what SolidWorks is? Have you ever used it?
I just literally looked it up like 10 minutes before I came here. So
Awesome.
like, oh, let's see what this is. And I saw computer assisted design. So like, okay.
Yeah, okay. Yeah, totally. Okay, perfect. So, Dassault Systems owns SolidWorks. SolidWorks has a big, user group base that allows people to connect, of course, and we want community. So these questions are oriented to how I can gear the presentation or talk to you about SolidWorks. So I'm assuming, have you ever used any kind of CAD like Fusion 360?
No, I've seen it, but I've never touched it.
Okay, and for you guys to understand, have you guys ever used CAD yourself? Have you used totally noob? But any questions about Python, ask Chip, right? What about you, Mark?
Yeah, I've been using CAD design stuff.
Mm-hmm. A strong advocate of utilizing free CAD software out there as well. I don't get paid by SolidWorks or Dassault Systems, but to respect what SWUG is, I really like SolidWorks, so I usually lean towards the SolidWorks avenues, but yeah, there's tons and tons of opportunities. So, okay, that helps me. And then I keep this slide here. I'm a picture person. I don't know if you can see very well, but if you kind of split the screen in half, from the top side is like my professional work, and the downside is what I do in my free time, just to get a vibe check on who I am. I love swimming in Lake Mead. I like taking group selfies. I like archery. I love board games. And on the top side, you can see what I do. I work for Aristocrat Technologies. I'm in the new product development team as a now senior mechanical engineer of January. But it's funny because I don't like to lead with that. I like to lead with the fact that I'm a creative person. I love design. I love drawing with my hands or painting. I love photography. I love videography and editing the videos as well. So just run through again what I do. So I use SolidWorks to design slot machines. This is parts assemblies made of sheet metal, aluminum castings, plastic injection mold. There are design elements about the slot machine that I really like, such as unique and beautiful lighting, as well as the fact that it's supposed to be tamper-proof. Like, I literally have to consider someone with a screwdriver or a wire hanger and make sure that they can't break into the machine and access the money or corrupt the system. So, and it's a highly regulated system. Hello. So I'm a 10 years SolidWorks user. I have attended this conference called 30X World 4 times. At the beginning of February, it'll be my 5th time. And I have my CSWP. As I've mentioned before, I love board games. I think I hiked 35 miles in January of last year. Or no, before June of last year. And yeah, as you can see from the last slide, I'm a chronic group selfie taker. More on this later. As mentioned, SWUGN, the SolidWorks user group, there are 250 plus groups across the globe. The common mission is to build and uplift the community of local SolidWorks users, but I like to take it one step farther. My mission personally is that Las Vegas has a better, brighter maker space, a makers community. So I'm trying to grab people here and here and here and like, hey, let's make our maker spaces more vibrant. So, and I do this because I love connecting with people. I love bringing ideas to life. We all love sharing knowledge and, you know, supporting each other's growth no matter their experience level. This is an update. So as you can see, I appreciate that you are all here. There's an existing SolidWorks community in Las Vegas, and it has been pulling teeth to try to get them to show up on a Saturday. So I want to tap into that community. So at this moment going forward, there are no scheduled SWUGN meetings at Tech Alley. I'm going to kind of shift. I'm going to pivot. I'm going to go virtual on a weekday to see if that'll revive the group that already exists. So if you want to get event notifications, sign up here. You'll hit the join and it will make you create an account. But that way, I always post all of our events on here, and you will get emails and automated reminders and survey prompts, I think. So if you want to go ahead and use that QR code and sign up later, please do. Deep breaths. Okay. So the point of the content for today, I've said this multiple times now, I'm giving you the process from going from one idea to 3D print for beginners, trying to simplify it as much as I possibly can. If we have this opportunity to, I will hop into some of the softwares, but right now I'm going to base it off of this PowerPoint. I would like to know from the people who are here, have you ever 3D printed before? I think you said you want to.
I have not, but do want to, yes.
What about you, Mark?
Many times.
Many times. Okay, he's the fact checker here. So if I'm lying to you, he'll raise his hand.
2 times.
2 times?
But there's one thing that I really want to do. So it's
Oh, okay, perfect. Okay. 0, yes. Oh, we had a full lunch conversation where you got someone to help you with the 3D print.
Yeah, I'm curious.
Yeah. Okay, and Miss, have you ever 3D printed anything yourself? Okay.
I've had someone do it on my behalf, but I've never been the one to do it.
All right.
I actually used Intagli.
Perfect.
So Josh,
And I'll shout out that resource and kind of talk the best that I can about it, but Josh would be best. I want to know, do you remember what your first 3D print was? Yeah. And when? Okay, car part. That's awesome. Okay. Your first 3D print, what's your name?
Just a keychain?
Oh, keychain. Love that. Yeah. Okay.
But it's got an NFC tag in it.
Oh, nice.
So yeah.
Oh, super functional. One thing to point out is the image. You'll see this again later, but this is a cross section of the FDM style 3D printing. This picture represents kind of, I don't know if you can see it very well, but there's that layer by layer by layer by layer. That's a really good close-up of what to expect from a 3D print. So no matter what, you're going to need a computer access to a 3D printer, obviously, and then an idea. These were in 2015 when I first started college, or that was, yeah, my second semester of my freshman year. These were my first 3D prints, so not super functional. Just a side note, these were the top ones as Blastoise, and then the Triforce symbol from the Legend of Zelda games. Those were gifts for my younger brothers. But on the second hand, my club called the Association of Engineering, Graphics, and Design, we would do something called toy production, and all of what you see in the different colors on like this tank, we would make out of wood. So one semester we would design it. The next semester we would make 220 wooden tanks, and each year the design changed. So over here is a tank, over here is a tow truck, and these were some of my first prints, breaking it down and making it was an exercise of design and manufacturability. And once again, all of this was our prototype before we went to that wood model. Super fun. I really enjoyed that. I miss that actually a lot. And there's a picture of me and my friends. And then some of the ways that I use 3D printing today. So it's usually my fastest way to check fit, form, function before CAD released for expensive tools. I utilize it when I need to physically represent an idea to some teams that don't necessarily have that skill. And then I love it as a creative outlet and making gifts, so that still resonates. In fact, over here is a Christmas ornament to in memory for my grandmother. And I printed out 12 of them, gave them all my cousins, and we kind of have a token of her. And it was really therapeutic for me to do, actually. Here's again, so I personally at home, I have an Ender 5, not a Pro. I still have to level my bed, but this is kind of what that looks like. And then again, the cross section here again, simplified. The green represents the filament. That's the plastic, and it gets pulled through the gears. It gets heated up and melted-ish. And then it stacks it layer by layer by layer. And then you have your platform. So yeah, this green is a 3D printed part, the filament, the heat, and then the platform. So there's a lot of things that you have. I say a lot of things, but there's some things that are required to make it work, but it's not a ton. So step number one, I think in Tech Alley, in the startup community, you have to have an idea, right? Like, you have to have an idea. I'm not gonna emphasize, I think you all understand, you have to have an idea. Something you wanna fix, a problem you wanna fix, organize, create, and I just show via my picture. I use sketching, I think a lot of us do, and it starts off really simple. But then you have to dictate the design intent going forward. Okay, you have to add parameters to it. So what does this need to do? How strong does it need to be? Does it need to fit something with, does it have to fit with other tolerances of what it will be adjacent to in the assembly? How will it be printed? How will it be assembled? How long does it have to last? For example, I'll just preview your clip. Do you want to talk about that really quick?
Yeah. We were talking at lunch.
Yeah.
In your car, in your car doors, there's the mechanism that moves the window up and down. Right? That's steel, and the window's glass. So if you put steel and glass together, you're going to break the glass, right? So they have these little plastic clips, and the car I had before, every year these clips would break, and I'd go to roll the window up, and it would go crunch, and the window would go, crooked, right? So I just got used to buying the clips off eBay and like replacing it once a year. Well, then I saw this thread on Reddit where this guy was printing clips for his car. It was another Chevy car, different from mine, but a Chevy car. And he had printed these in his 3D printer using a harder plastic. I think he used PVC. So I was like, hey, can you make some of those for me? So I sent him a couple of the clips that I had, so that because he had the digital calipers, so that he could get the measurements right. Mm-hmm. And he printed some out and sent it to me, and I put them in my doors, and they lasted until that car got wrecked like 2 years. So that's
just
a success story. That's part of what's driving me being curious about this.
Yeah, it's funny because I feel as though the original engineers that made the original clips were like, you would expect, oh, let me use this out of material that's going to last for a little bit longer. But sometimes there's trade-offs of, okay, this is going to be really expensive. Let's use a different material, and then you have breakages like that. So maybe you don't want your 3D print to last forever, maybe you do. So that's just the last question. How long does it have to last? That's why I brought that up. So this is, I have this stated like this. I'm telling non-CAD users, I'm assuming that's you, that you have options when it comes to the 3D model, right? So you have the option to learn CAD on your free time, right? And I'm gonna shout out SolidWorks, of course. So utilizing SolidWorks software and other CAD and tutorials online for parametric design. Parametric design requires you to have measurements that you assign to your model. So if you have a radius, you're going to input that radius, you're going to have a length, a width, a dimension. That's parametric modeling. There are some lower barrier modeling techniques called sub-D modeling or mesh modeling that you could use via X-Shape or other software. And it feels like you're molding clay and you get more organic shapes. So if you've ever seen people make tabletop figurines, they're likely using one of those instead of assigning, like if they have a sword, they're not assigning that this distance to this point of the sword is a certain measurement. So they are utilizing those kind of clay modeling, organic shape. And that's nice because you can drag and pull. And you can see on this screen, you start with a square, and then it divides it, and then it divides it, and it divides it. And each little square allows you to manipulate it. So you can pull, drag it. And another software that's similar is like Blender. So learning CAD. If you don't want to learn the CAD, you could commission someone else who does know how to do CAD. Or you can look online for something similar. You can look to see if someone created something similar online. So utilizing websites like Thingiverse or things.com, GrabCAD has a lot of car parts, or if you're trying to utilize a Raspberry Pi, someone has reverse engineered existing things and put it on GrabCAD, and you literally just grab it and go. Or you could pay for someone to do, sometimes now people will do that and charge like $5 for the file, and you could buy that off of them and you can have it forever. Utilizing Reddit per usual. I just am going to pause here. I'm just going to try to give you guys a little bit of information about what SolidWorks does have to offer that's low barrier. I think a seat of SolidWorks, a business license of SolidWorks is like X thousands of dollars. I don't have that money to do fun things on the side. What I do have money for is if it's nothing I want to sell, I could get the maker's license. That's $48 a year. It's not for commercial use, and the files are watermarked, but it gets me through my that ornament that I made for my grandma. Like, I had the software, you could do it like that. Now they have a program for startups, and the way they layer the payment, it's year one. Let's see. Okay, for year one, it's free. For year two, it offers a 70% discount. So it would be $846 or $1,400 a year. Then after that, year three, it drops to 50% discount. Once again, I'm not a SolidWorks reseller. If you're interested in that, please let me know and I'll link you to a reseller or something like that. But I just wanted to let you know they are trying to pour into those kind of communities, so that's an option. And of course, actual price may vary by region and eligibility. Deep breaths. Okay, so at this point, right, you have your CAD model. It's fairly simple. You just have to export the model to 3D printing. So actually doing this presentation, I learned I had always used STLs. It was just what I know, is what everyone accepted, the slicers accepted. But I actually learned that the technology has updated and you can do more complex things if you save your part file or your assembly files as a 3MF file. So here I laid out some of the differences between the two. For example, so STL already said, common saves the CAD into many mesh-like triangles. That's what this image is here. But a 3MF file is modern. It stores a lot more information for a smaller file type. It stores color, texture, materials even, printer settings. It's more compact. Now, if you have an OBJ file, it's more for your artistic 3D renderings. It stores color and texture, but based off what I saw online, it was more for your artistic and intricate designs. So maybe something that's supposed to be more lifelike or more character than like a table. And then as an engineer, I utilize step files a lot. I get step files, so I learned that I could print my step files, and that takes out the middleman of it all, and that makes it a little more functional. But I think going forward, I'm likely going to use that 3MF file. Just seems like. Does anyone have experience in which file type they like themselves? Josh, you gotta.
I stick with the STL file.
Yeah. Did you know about the 3MF?
I do. I'm familiar with it, and the step file. I guess all of them.
You know what you know when it comes to STL, but I guess if I wanted the process to be a little more advanced, so if I assign my material color and I'm printing multicolor, that might be kind of cool not to assign it in the slicer if it just carried those properties over.
That's what we look at most of it. Someone already had it sliced and colored and set up. And
Yeah.
Yeah, you're right. Throw that in there and I don't have to think about it.
Yeah. So in your CAD software, you'll hit Save As and you'll select one of these. Most commonly, you'll do STL or 3MF.
Can I ask you a question?
Sure.
How does multicolor work? Do you have multiple filaments going in, and does like an RGB blend or something?
Okay, so I've just recently dove more into multicolor prints. There's this thing called an AMS, automatic material selection. So the printer is smart enough, it'll have your plastic material in like say 4 banks. Then the G code will register, okay, print red on XYZ layers, then print green on other layers. And the computer itself and the technology knows how to, but as long as you have that AMS and you have all your material primed, that's where it introduces. So that's with if you have 1 nozzle, but if you have 2 nozzles, then you can assign like one material color to 1 nozzle, the other material color to the other nozzle. Now you have your support material there, so that might be a little bit, I don't know, not super expert in 2 nozzle printing or multicolor printing, but it's all about that G code in that layer and it's saying, okay, stop with red, go back, insert new color, and then do the other one. Yeah. There's some more advanced techniques, but I'm gonna stop there for now. Okay, deep breaths. Alrighty, so I think this is what could be the most challenging is when you so you have your model and you need a slicer. The printer has to have a slicer, and that dictates all of the information. So here, okay, slicer translates 3D models into machine instructions, G code, for printing. AK literally slices the model by these layers. So you get these previews of every layer in your slicer. This is also where you apply the settings that dictate your overall time and material usage. So I'm going to be talking about FDM for this presentation only. There's multiple different types of printing. There's resin printing, which is called SLA. I mean, there's metal print, there's powder, there's just so much. But right now, the simplest thing that I'm sure all of us have the most access to is the FDM style printing. So you're gonna wanna be intentional about your materials. So I kind of outlined some of the most common materials and their use case. For 3D printing, PLA is what seems to be most popular. It's low warping, it's easy to use, and I just found out that it's biodegradable. I did not know that. ABS, this is, I think this is kind of like older, but you would typically, it's like, oh, I need a strong print. you would like, oh, I'm going to print that in ABS because it's known to have tough characteristics, be more impact and heat resistant, though it does require ventilation because of the fumes that come out, and therefore I kind of stopped using it. I'm sure all of these have some kind of fumes that you're probably not supposed to be inhaling, so just make sure everything is being properly ventilated. PET-G, balanced, functional, from what online said, it's kind of the combination of the two. TPU, that's flexible, rubber-like. You can actually, like, you see people who 3D printed their shoes. This is that flexible material. Nylon, extremely strong, harder to work with though. Right now at work we have nylon material, and this material you have to bake it for like 18 hours to make sure it's really, really dry, or else the water in the material as it's printing actually like pops and sizzles. So I find that frustrating because I don't want to wait 18 hours to dry my material before I print it. So, and then ASA, apparently this is more for outdoor use because it's highly UV resistant. I got all my information off Google, though all of these materials are things that I've heard of or I've used myself. So if you have a personal favorite, go ahead, shout it out if it's not shown here. But yeah, for most plastic or for most 3D printed use, it's usually PLA. Anyone have a favorite material?
There's a new thing that's graphene.
Oh.
I saw those over at CES,
Oh.
which I don't have any experience with, but it looks to be quite rigid and get really fine prints off it, but I haven't experimented with
What was it called?
it. Graphene, Graphene.
Graphene.
And ABS,
Whoa.
the problem with ABS is that it warps a lot.
Really? You've experienced that?
Well, ABS, there's this, the whole trick to getting it to hold on to
The bed adhesion?
is, well, the best trick is to get to 3M blue painter's tape.
Yep.
Wide,
Yep.
tape it to the platter, and then spray it with Aquanet hairspray.
Oh, nice. I like that. Wait, so what he's talking about is making sure the first couple layers of the 3D print adheres to the bed, and a lot of people use a glue stick to just get it to work. That's funny. I know that people literally put painter's tape in some format where it's sticky on the bottom and sticky on the top too, right?
It sticks to the bottom.
Okay.
And it's got a rougher surface on the top.
And then hairspray.
And then there's something about the Aquanet hairspray that it's got some sort of plastic in it, which must be biodegradable when you wash your hair. It
Probably awful.
keeps those first layers of melted ABS strictly onto the platter.
Wow, I hadn't heard that one.
Tape off the platter and take the part off.
That's awesome.
But it likes to warp.
Yeah.
And the thing about ABS is that if you put it under in a glass container
Yes.
and you put
Acetone?
in it,
Oh.
it's toluene, yeah, and or method, I think it's toluene, like lacquer thinner or something like that.
Yep.
The surface will
Melt.
gently melt and it smooths out, your lines disappear.
Totally. Yeah. So just to repeat, so one of the perks of ABS, who knows what damage this is doing to you or the environment, but you can take your print, at least the way that I saw online. So like I put my print on like a little pedestal. I have some kind of container that is, the way that I saw it is someone like taped paper towels and then drenched those paper towels with like acetone and put it over their 3D print. And as you expected, or as you can see in these first, here we go, line by line by line, that can be really ugly, and it melts that outer surface and it allows it to kind of have a more glossy, smoother surface. So it almost looks like it's a plastic injection mold versus a 3D print that you see layer by layer.
So it is acetone, not toluene.
I saw acetone online, but I don't know. But that's a little hack with ABS if you're ever interested, but you know, be warned.
Also with ABS is that you can do a chemical weld between parts.
Mm.
So, for example, if you want to make a hollow
Uh-huh.
You can make 2 domes, and the methylene chloride is the best, but you can't get that anymore because of carbon outlaw. But there are some ABS solvents so that you can put the 2 halves together and hold them there for 10 or 15 seconds.
And it fuses
So
it.
it's chemical.
Literally changes the chemical component to merge it together. You've got some advanced techniques.
Yes.
Yeah. Well, it made me interested, based off this like little bit of research, just laying it out, made me more interested in that PETG, P-E-T-G, going forward. Because I like how easy PLA is to use. So it seemed like it was a combination of the both. So let's jump in really quick to, so your 3D printer is, if it's FDM, it's going to absolutely, I keep going this way because this is mirrored. It's definitely going to have a nozzle. So that nozzle is going, I'm going to switch over, that nozzle is going to have a different diameter of the opening. From my understanding, 0.4 is your more common diameter. So I went ahead and put out, you have your nozzle diameter and the relationship between that and the layer height. So for a 0.4 millimeter nozzle, it will ask you in the slicer your layer height. If you want a highly fine detailed, it would be a layer height of 0.5 to 0.15 millimeters. Your standard is 0.15 to 0.25 millimeters. And then if you don't care about how it looks and you just want to get material on the bed and you don't care how tall that layer thickness is, it prints faster, and that's what that's saying. It's 0.3 to 0.4 millimeters. That's fast, though you sacrifice a lot of things in achieving that. Some of the popular slicers that I use are Ultimaker, Cura, the Prusa slicer, and then Bamboo Labs. I'm going to be honest, I've almost entirely switched over to the Bamboo Labs, even though I have an Ender 5 printer. So these, I think, are all open source, where you don't have to have the slicer married to the printer. You can, it's like kind of open source, and you can import your printer to the slicer, and it has some default settings saved in there. So here's where the images are from. And then on the bottom side here, keep in mind of what this is infill. So we have 0% infill. That means you just have your wall thickness, and then 5%, 10%, 15%, 20%. All of this looks in a more hexagonal shape. I'll be talking about infill on the next slide. Oh, but first I will be talking about the supports. So. Yeah, thank you guys for bearing with me, by the way. So for your supports, one of the key things that I think you need to know is just when supports are required. The supports, this is additional printed material to support unique features of your model. So if I'm gonna, say I'm gonna print myself, it's gonna start at my feet first, and then it gets to here. I'm going to need to have this arm supported, or else the extruder is just going to hang and spit material off, and that's going to droop. So if I'm printing myself like in this format, it's going to support materials all so that when it gets to this wall thickness up here, it has a surface to print on top of. So usually if it's less than 45 degrees from the vertical, it can usually print without any supports. I have some pictures of that. But if it's higher, if this angle goes above 45, then you're going to build that extra materials support. So you want to try to, so my personal philosophy is that you're going to try to orient your print to maintain your design integrity, but with as little support material as possible. I hate breaking off support material. I hate when I'm trying to clip off support material and actually clip off my part. It really makes me frustrated. So, but if you orient your your print to maintain the design integrity in a way that uses the least amount of support material, you are spending less time printing and less wasted material. So,
Can I ask a question?
sure, yeah.
Sometimes does that mean design upside down? So
Totally.
Okay.
Actually, I'll just switch over to this image over here. So can you guys see that okay? Okay. So this is actually a part that you saw in a sketch earlier. I had to orient this print in this way for a couple reasons. One, so it just fit on my printer. But two, this was the last way I thought this wanted to print. I would have expected to print it like this. But because it had like a curved radius, so it was kind of like this, because it met that 45-degree angle rule, it only had to have to print 6 little lines of support just to get it there. And I would have expected it to want to print just like this. And you could have, it may have gone faster like that, but I was kind of impressed. What was your question again?
Whether or not you should flip something upside down.
Yeah, so you have that autonomy. You may have to, yeah, you totally can. As long as it meets your design integrity, essentially. Does that make sense? Okay. Okay, so even if we, kind of like that L, if we wanted to print that upside down, you can. Should you? Maybe not. It depends on the design. It would have needed to support all of that versus that. Okay. So the infill percentage. Also, this PowerPoint will be available for you guys to use it as a step-by-step guide if you need it. So just send me a message on LinkedIn. But okay, material on the inside of the part. So usually defined in a percentage, and it'll be a little icon. It'll say 10 to 20%. This is fast, typically non-functional, like that blastoise you saw. That's going to be maybe 10% infill, just so that I am not wasting material, so that the print goes faster. So yeah, your typical range for non-functional parts is going to be 10 to 20%. If you need more structure, if you think that this part will meet some forces, you might up it to 20 to 40%. But it's going to be slower because it's literally filling in more of your part. 40 is going to be 40 plus is going to be your slowest, and you will do this when you need your part to be a little bit strong, or to be pretty strong, and to withstand significant forces. And then number 5 it matches with the picture here. It is how you orient your part. You want to align it with your best design integrity. So consider the layers of the print as grains. Sometimes that matters aesthetically or functionally. So for example, here you can see the lines. If for some reason a load is going to go this way, it's going to separate at this lowest point here. But if you change your part orientation and you have your grain running vertical, the load is going to more kind of stretch your material versus cleanly break off at the layer. And the last thing is click print. So here's some things just to check before you hit print. It's check your bed level. It's check your print temperatures for the correct. Check your print temp is correct for the material. I've done this and clogged so many nozzles because I changed my material and didn't change the print temperature of the nozzle. Check your ambient temp. It will not so that it doesn't interfere with your temperatures. For example, my printer is near a window, and if I print in winter, I literally have to crank my heat up so that, because I don't have an enclosure around my printer, so that the bed adhesion, it's supposed to be 60 degrees. If the ambient temperatures makes that bed a little bit colder, then my print won't print successfully. Let's see, make sure you have enough material on your spool, which is defined in the slicer. And then they say the first 10 minutes of your print pretty much tells you exactly how that print will go. So I like to keep my eye on it, and I hate nothing more than when I am trying in that first 15 minutes, try to make the print work. I'm grabbing my glue stick and taking material that's already printed and pushing it down because I just don't want to work on it, just want it to work. And then I get 80% of the way, and that place where I added that glue just knocked off, and my print I wasted time and I wasted material because I literally can't use that print anymore. So yeah, I hate getting 90% through the print and then it failing because I didn't just address it in that first 10 minutes. It might mean stopping the print, adjusting the temperatures, adjusting, maybe adding better glue, better adhesion. Maybe it's because I forgot the Aquaphor, or not the Aquaphor, the Aqua hairspray, but just address your prints in that first 10 minutes and it'll, if you get that going smooth, you're more than likely going to have a successful print. And then here are some common problems and then some things to check. So if you have poor bed adhesion, check your bed level or the temperature. If you have little or no material coming out of the nozzle, you likely have a clogged nozzle. Clogged nozzle could be related to your print temperatures or moisture in the material. Your part is warping, maybe when you get it off and you wanted it to be flat and it's bowed, that could be because your print temperature is off. So, part warping, yeah. Your bed adhesion could have been a little messed up, or, you know, the part, maybe it's too hot or potentially too cold. We love something called spaghetti when it comes to FDM 3D printing. So if it's like stringing, check your temperatures. And then if you have weak parts, you might want to up your infill or change the orientation. Any questions?
The leveling is really important.
Yeah.
You have to check the levels north to south, east to west,
Yes.
diagonally.
Yeah.
Because if something starts getting higher,
Yeah.
a small
Oh, I have so many.
corner is going to
I'm gonna go off book just because you said that. Did I save this picture? Hang on, don't look at this. Just kidding. Aw, man. Done.
How come they're not just like self-leveling?
Aw, man. Technology, it's based.
They look level to the tabletop. So when you have your machine on, if the tabletop's not level, your whole machine's slightly.
And there's definitely printers that have that auto leveling feature built in, like the latest and greatest, or the Bamboos. They will, I think, you can set this, but they will, so imagine you have a square, they will check in like, 9 points across the bed before they start every single print. That's nice to have, but not all printers have that. So my Ender 5 doesn't have that feature. So I have to manually do it. I have to take my nozzle, go to this point. Typically it's a business card thickness. You want it you kind of like rub it. And if it has just a little bit of friction, that's your proper layer height, right? And then, yeah, for mine, I have little wheels underneath. So I'm like I'm kind of like twist, raising it up, lowering it. So, and then I'm manually checking all those, but the technology is there, it's just based off your printer. Yeah.
Will the software warn you if you've made questionable structural decisions in your design?
I would say it depends on the software. There are some things, your design or like your slicer settings?
Well, as you're making something like this that has a support structure in it,
Yeah.
if you don't put enough supports or the right kind of supports,
Okay. It depends on your slicer. A lot of times the slicer is smart enough to highlight areas that need more help as red. There's also auto support. Actually, I think I exclusively use the auto add support. Like I don't manually type or go in and select, okay, put support here, but I could if I wanted to. But usually the slicer model will show you red in the areas that it's like, hey, this overhang doesn't meet the criteria, add support here.
okay.
Yeah, you can customize the supports, or you can click the auto support button. Actually, Josh, what do you do?
For the Bamboos, I think I used to mark them because I would like to reduce the time.
Yeah.
Bamboos do a pretty good job, but unlike you, not that I don't like supports, I hate the scarring.
Yes.
But now that they have different types of supports, like the tree supports and things like
Yeah.
that, those are really good. So I think on the Bamboos and Lotto and
Yeah, let's see. I did pull this up. This is what the bamboo slicer, I'm gonna sit down. This is what the bamboo slicer looks like. And here it doesn't have any support material defined. Let's see. So here we're talking layer height, layer width. The bamboo slicers kind of advanced. Like I usually don't mess with their default settings, but if I have some issues, I know where to look. So let's go over here to support. So let's see, I did default. Let's see. I was just gonna see if it highlighted red for areas that it needed. Let me just go
You have
slide.
a bamboo at work
Yeah,
and an indoor at home.
yes, yes. Yeah,
What you did, so you have the PETG interface,
yeah.
that means that it's not going to stick in the PLA.
Yeah, so this is kind of this is a really good trick to know. It's a little bit more advanced, so don't tune it out. But essentially, so this is my part, you can see over here. But Bamboo has this slick feature that says interface, and because it has two nozzles, it prints an entirely different material. So it goes support material, like let's say it's PLA. Then it'll print one layer of PETG and then my part, and because my part back at PLA, and because it had one layer of a different material, it then, like the materials don't fuse together, therefore it allows you to have a little bit easier, cleaner break off. The material, like I said, the material doesn't fuse together, so when you knock it off, it's a smooth PLA only surface, and that's what you see here. That's why they're different colors.
Enough to hold the part
Yes,
in place.
thank you.
It's much easier to separate it after.
Yes, and it's just this like one layer, or no, these maybe what, 4 or 5 layers just here. But yeah, this is kind of a zoom in of what the slicer is doing. It's literally taking that geometry and slicing it layer by layer. You have the option to, you know, change, like do a cross section of your part. I'm going to orient this up. In Bamboo, you can change your infill pattern. And let's see, I think I got knocked off the original question, so please go ahead and shout that out if I didn't answer it. But I was gonna show you the infill. Let's see. Okay, bed adhesion, quality. Yeah. Oh man. Yeah, Bamboo does a really great job of kind of knowing, oh, here we go, sparse infill. Yeah, so I went 15% here, and I went with grid. But if I wanted to, I can do Hilbert. Let's see if that will blow my computer up. Or, yeah, I have 3D honeycomb. Let's see if that will be. Oh, I think these parts are way too thin to have that. Yeah. Yeah. Oh wait, let's just see this real quick. Oh, hang on. I got confused. We were looking at the support layer for we're looking at the infill of the support, not the part itself. This is dictating the infill of the part. I don't actually know how to dictate the right here. So we went here, let's go here, slice that. Oh man. One last thing just to shout out about Bamboo. They have their own tree support where it's like an ergonomic structure. It's not like squares. It's not like, I don't know how to explain it without showing you guys. Here, let me just Google it really quick. It looks like something out of Groot. Like this. I don't know the science or the technology that Bamboo is doing, but this seems unique to Bamboo. It looks really cool when you knock those prints off, but yeah, it's literally called tree supports. And this is utilized to use less support material, but still support where it's needed. Where typically, for this example, you'd probably see all of this negative space filled with support material because it didn't know how to. But Bamboo has created some kind of something that calculates the tree where you need it. So I don't know. I think that's really cool, and I do like breaking these off because it looks creepy. We started putting them around our cubicles, and it looks like hands, kind of like ah. Anyways, sorry, the little Raquell moment there. Okay, so back to the common problems. Yeah, I would say these are a good amount to get you started, and yeah, you could do some research thereafter. So in the design process, once you have your print, evaluate and iterate it if you want. So remove the support material, check your fit, form, and function, and update the model for any improvements. And this is a typical design life cycle. Whether you agree with it or not, this is a typical one. And we basically went through this process, right? Design planning, conceptualization, that's your, design intent, select your materials, and so on and so forth. And then once you are happy, so if it's your own startup company, then you move on to the next step. So just a summary of the whole process: create your idea, identify the design intent, create CAD model, export files, slice, print, improve. Alrighty, second part of this, it is 338. I like to shake it off. I've mentioned this multiple times. I don't like public speaking, and I love SWUG because it's building community. So this is where specifically I want you guys to be more involved and engaged. But I do have some links here for resources that I use and I support me specifically. So if you are interested in utilizing oh wow, I'm impressed that we actually got.
My name is Nick Leister, and I'm a member of this.
So the SolidWorks YouTube page has an entire beginner's guide that's free for anyone to use. It takes you through the software itself, and then it takes you how to model this set of pliers. And it literally takes you from sketch to 3D. So here, let me just go here. So that's one thing. If you're ever interested in utilizing your time to model something up here, I would follow this. If you've never utilized it before, let me go back to my PowerPoint here. The 3D printing community on Reddit is really fun. I was even thinking maybe we spend the last 5 minutes just looking at cool things on Reddit. It's very inspiring. I'm sure maybe that's where you got your interest because you saw it on Reddit. Yeah, that's awesome. Now, in the research of trying to put all of this experience into a format like this, I uncovered the Reddit community, and we all believe the Reddit community loves this guy for 3D printing basics. So later on, if you wanted a resource and you're like, hey, I need more involved steps, go to this guy because he was really legit. So I just wanted to give you guys a preview of that. Next thing, this is a resource that I use all the time. This is called, Solid Professor. And let's see if I'll pull it up actually. So I get free access to this because of my work, and I'm really lucky to do so. Oh, okay. Let's not do this right now. Hang on, back it up. Why are we at LinkedIn? Aha, that's what's going on. Okay, so Solid Professor, once again, I get free access to this. I think when I looked it up this week.
Before wrapping up, I'd like to show you how to use a tool.
It was $480 a year to have access to these tutorials that are very, very advanced, from beginner to advanced for SolidWorks and other platforms like AutoCAD, Mastercam, Inventor. Even if you wanted to know about Raspberry Pis, they have some form of content on here. I'm lying. So I just wanted.
Before wrapping up, I'd like to show you how.
I just wanted to shout out to this. This is how I got my CSWP. This is what I'm utilizing to get my CSWE, that's SolidWorks User Expert certification. So just letting you know that this software exists, though if you're not in a position to pay that much, or if your company's not paying for it, then utilize your free resources and training guides. Things.com. This is, come on. Oh, you know what? I think it's not things. I think it's things. Yeah. Let me just make, yeah, okay. People are making things all the time and uploading them for free, or you could pay for them. If you want this little robot guy, usually you can just, okay, so you can purchase this model for $8.99. You can download your software and print it. So that Blastoise came from Thingiverse. That Triforce from Legend of Zelda also came from a website like this. So this is kind of fun just to look through. Once again, typically this is usually free. I think people are getting so good with it that they're, putting things behind a paywall. But I just wanted to show that out, share that with you guys. Yeah. I did not think you were gonna be here, okay, but I did want to shout out. I think you could do the best of presenting your company, but yeah, this is a really nice tool if you need something printed. I'm getting nervous because you're here. Do you want to speak real quick? Yeah, I wanted to shout that out because I think that's really cool, because if I have design intent that I can't just get out of submitting through a portal, and I want to talk to someone and say, hey, need this area to be strong, as someone who's expecting a product, I think that's really useful. So I just thought that was really cool. And yeah, as I was looking through like my first 3D prints, I remember there was this website called thisiswhyimbroke.com, and oh my gosh, I just was, in 2016, I just thought I would leave you on a funny note. There was a pancake printer, and I said, how have I lived my whole life without one of these things? And then check out thisiswhyimbroke.com. The name is very appropriate. And I just thought that was funny that like people were doing this in 2016 or even, earlier, and I still don't have one, and I have adult money. What the heck? Anyways, but yeah, so that's the end of my presentation. Did anyone have any resources that they were inspired to share with the group themselves? Whether it's where you get 3D models, the CAD software, any personal experiences that you haven't already shared. If not, then yeah, I think we could wrap up. Yeah, all right. Thank you guys so much for showing up. I appreciate it. Yeah. Once again, last thing, use this QR code to sign up. The next virtual meeting that we will have will be sometime in April. It'll be on a weekday, and it will actually cover some SolidWorks modeling technique. It's called master modeling, and one of the guys from the resellers is going to present for an hour, and you learn a technical skill. So it's kind of nice to have SolidWorks or some kind of CAD in front of you. So yeah, thank you.